In this video I will show how to add on to the swimming system so you can swim in water currents. You can see the current visually as it has wind lines going all around it. The speed of the line depends on the speed of the current. Once I am close enough to it, the player will be pulled in and move along the current. The animation is different here. If I try to move backwards, the pose changes. There is currently a strong vortex strength for this current, so I cannot move off center even if I try. Procedural leaning is also included, but only in the project files. Here the current ends and the player can swim away freely. You can enter the currents from the side as well and it will work. Here is another example, but it is a lot slower with very little vortex strength. Therefore I can swim out of the current if I want. The currents are made using splines, so you can make any path and shape that you want and for any maps. Here is another example where the path is a lot more linear. Since we use splines, we can just change the points to linear if needed, which is what I did here, so the current goes along this tunnel. Finally, I also show how to make river currents. This uses the same blueprint but will affect the landscape to form a river which has the same current system. Also, I was able to adjust the settings like fall off angle so it blends in more to the landscape, as well as change the material so it looks like the water is flowing faster to match the speed. The current is only along the river spline, so when it joins the ocean here it stops. This video is an add-on to the advanced swimming system I made previously in the water series, so you must have followed that along first for this. First we will get some animations. You can use any, but I will get them from Mixamo. I only needed this floating one. Make sure to download it without skin. I used the Mixamo converter to convert it from the Mixamo to Unreal Engine standard rig. I will link this software in the description below. Next, import it. I renamed it, then rotated some of the bones so it is facing downwards and looking up. Press the Add key button at the top while being at the animation's first frame to apply the rotations. For backward current, I will duplicate the treading animation and just modify it. Make a blend space 1D and copy the setup. The smoothing time is how long it takes to blend between each pose, so it shouldn't be too high. I set it to 1 since water currents are usually strong and free movement should be restricted. Next we need the Niagara effect. I am not that good with VFX, so I used this great tutorial by Gislin Girodot, which I will link in the description below. He shows in detail how to make Niagaras move along a spline, but I modified it slightly so it looks more like wind and without much randomization. Here is my material set up for it, which you can pause and copy if needed. It is made specifically so it can be seen underwater with the post-process effects. This is optional and just simulates some waves effect, although it is not that perfect. Here is the Niagara. Change the material. I also increased the bounds by a lot so it is always seen. Next, make some user parameters as shown and set the following ones to them. The forward min and max controls the speed, and we use a vector 2D where the x is min and y is max, so we don't need two separate float parameters for it. The magnet min and max is the vortex and will pull the particles in towards the center. You can change this spiral curve if you want to a linear one, but I just used this quadratic one. I will make a new level to test it. Add a water body river. Again, this uses the water plugin as specified in the swimming tutorial. In the details panel, click this button next to the add one and you can make a blueprint using it. Open the water interaction BPI and add the following events. Add the shown outputs to get swim variables. Add the current Niagara. It should automatically reference the only spline in the hierarchy, as you can see. You can change the settings here too, although they will be done dynamically, so it adjusts based on the length, speed, and vortex strength of the current. I will now do the prerequisites from the VFX video off camera, which you can follow from his same tutorial. For the spline, I used the spline comp. Add the shown code in construction script. This removes the current particle if it is a river instead of underwater current, since it will not look that realistic for rivers where you can already see the flow direction. This code dynamically sets the parameters. You can adjust the defaults if you want. Make a function called check in current and copy the shown code. I will explain this when it is used in the code soon. This only runs the code if not a river current. We will use a for loop to add collisions so the player can enter at any point in the current and we have greater control over it. This selects how many to add based on the distance. The constant 320 can be changed to your liking. This is an extra check which will make the collision not start directly from the start for rivers, since the current should be once you are in the river fully and not at the edge where it transitions from landscape to water. This code now gets the world positions along the spline at equal intervals. The box extent can be changed to your liking. Make sure to change the default width in the spline comp to match it, however. If it is a river current, then we need to move the boxes down to be level with the water surface. This value should be negative and slightly higher than the box extent, so for 500 something like 520 should be good. The offset is so that the current starts below the water and not at the surface. This makes any actor that has the function implemented enter the water current once overlapped. This is for exiting the current. We made the check in current function since once we exit one box it should only exit the current swimming if you have fully exited the current and not exited one box and are in a new one along the current. Change the for loop first index to something like 3 as well. Also reconnect this multiply here. For the default actor, disable effects landscape. Also make these two variables instance editable by clicking the I so we can change the values in editor per actor. Create a child class of it and enable effects landscape. I can now add this one to the scene. You can now swim in it, but the current functionality will be added now. Go to your character blueprint. Make the shown variables. In Get Swim Variables, add the corresponding new variables. Now add event, enter water current and copy the shown code. We will use a timer to move along the spline. To actually move, I will add impulse to the character movement. Since we need the direction of movement, I will find the tangent, which is basically the normal and can be used as the direction vector. Current move rate is how fast it moves. For something like a human player character, a value of 0.01 should be good. You can change this value based on your character type and weight. Enable velocity change in Add Impulse. This second impulse is for pulling the player towards the center based on vortex strength. I used a constant value of 10 for the pull amount, but you can adjust this. Next, set the actor rotation as shown using interpolation to make it smooth. It should face the direction of the current, so we can just use the same tangent vector. To find whether you are trying to move forwards or backwards, add this code, which finds the dot product between the actor's forward vector and the input direction. Now add event exit water current and copy the code. This just resets all the variables used. Here it is in game with the river now. You can see it works as expected. However, the swimming rotation and current rotation is overlapping. To fix this, go to the swimming rotation function and add a branch here. Now it is better. Finally, we will do the animation blueprint. Open it and go to the swim variables section. Promote the 3 new variables here. Add this check here to disable foot IK if in current, as it caused some issues. I will also disable the swimming procedural lean temporarily since it was a project file exclusive, so isn't needed for the actual tutorial. Go to the swimming locomotion state and add the shown code. This forces the forward current if in a river, otherwise is based on the input. I actually changed the river forward animation off camera later as shown in the beginning showcase. The forward animation is not centered in the Z-axis, so I will just move the pelvis bone down as a transform. You can click this gizmo at the top to change it from local to world transform. Now it works nicely. You can change the speed and vortex directly from editor here. Here is one with a stronger vortex. Here is a faster one. At the end of the spline it pushes me out since it is ramp. Also, if you want, you can still add the current particle for rivers, but you will need to write some extra code to adjust the spawn range to match the rivers. I will now show the default current which you can use underwater. Here is an underwater seabed map with a massive creature skeleton. I will add the water current actor. It is very important that you do not rotate the actor at all, as it will not work correctly. The rotation must remain at 0, 0, 0. You should only modify the spline path. I will adjust the spline path to follow around this skeleton. It might be easier to do in unlit mode. To make new points, just hold Alt and drag. You can click on the light purple points to modify the tangent and curve direction. Here is how it looks and works in game. It is very slow, so I will increase the speed, which will also make the particle flow more linear. You can see the range is incorrect, so I will first make the box collision not be hidden in game, then adjust the box extent. These boxes are the detection ranges, so just play around with the extents until it works correct for you. Currently the particle spawn range cannot be dynamically set, but it is easy to make it into a parameter, then make the box extent an instance editable value, so you can change it per actor too. This is included in the project files. Now it works properly. Finally, I will show a linear example. This time I want it to be in this tunnel with no curves in the spline path. To do this, first I will roughly make the path. Then right-click, select all spline points and change the type from curve to linear. This makes each point straight. You can combine linear and curved points if needed as well. Here is how it looks in game. Again, you can easily change the speed and vortex. The current swimming system is now complete. Some suggestions you can add to this is camera shake, different sound effects for when in current, and making other objects be able to interact with the current like fish. That is all for this video. If you enjoyed, like and subscribe for more content. You can purchase this final results from Gumroad using the link in the description if you want. It is included with the swimming project files. Example maps are included. Thanks for watching.